Have you ever wondered why some animals living on islands are much bigger or smaller than their mainland relatives? In this episode, we explore the phenomena of insular gigantism and insular dwarfism, which occur when animals evolve different body sizes on islands due to different ecological pressures. We also discuss how these phenomena help support the evidence for evolution and why they matter for conservation. Join us as we discover the amazing diversity and adaptation of life on Earth. I'm your host, MrEarthGuy, and you're listening to Earth SciShow. Now, before we go into the topic of insular gigantism and insular dwarfism, let's start with the basics. What are these individual phenomena? Insular gigantism is when animals living on islands grow larger than their mainland relatives. Conversely, insular dwarfism is when animals living on islands grow smaller than their mainland relatives. These phenomena are examples of island syndrome, which describes the differences in morphology, ecology, physiology, and behavior of insular species compared to their continental counterparts. You may have heard of some examples of insular gigantism, such as the Komodo dragon, the largest living lizard in the world, which can reach up to 3 meters in length and weigh up to 70 kilograms. The Komodo dragon lives on a few islands in Indonesia where it has no natural predators and plenty of prey. Or maybe you've heard of the coconut crab, the largest land-living arthropod in the world, which can span up to 1 meter and weigh up to 4 kilometers. The coconut crab lives on several islands in the Indian and Pacific Oceans where it feeds on coconuts and other fruit. And lastly, you may have heard of the moa, an extinct group of flightless birds that once inhabited New Zealand. The largest species of moa could stand up to 3.6 meters tall and weigh up to 250 kilograms. The moa had no natural enemies until humans arrived and hunted them to extinction. Some examples of insular dwarfism are the pygmy mammoths, an extinct species of elephants that lived on several islands off the coast of California. The pygmy mammoth could reach up to 1.8 meters in height and weigh up to 200 kilograms. The pygmy mammoth was much smaller than its mainland ancestor, the Columbian mammoth, which could reach up to 4 meters in height and weigh up to 10 tons. More obscure forms of island dwarfism include Channel Island foxes, a small carnivore that lives on 6 of 8 Channel Islands off the coast of California. The Channel Island fox can measure up to 48 centimeters in length and weigh up to 2.8 kilograms. The Channel Island fox is much smaller than its mainland ancestor, the grey fox, which can measure up to 112 centimeters in length and weigh up to 7 kilograms. And the list wouldn't be complete without mentioning Homo floresiensis. This is an extinct species of human that lived on the island of Flores in Indonesia. The Homo floresiensis could stand up to 1.1 meters tall and weigh up to 25 kilograms. Homo floresiensis was much smaller than its possible ancestor, the Homo erectus, which could stand up to 1.8 meters tall and weigh up to 60 kilograms. So that's quite a comprehensive list of distinct species that differentiate between their mainland ancestors. But what causes these phenomena? Why do some animals grow bigger or smaller on islands than on continents? There are several explanations for insular gigantism and insular dwarfism, but they all involve the different ecological pressures that affect island species compared to mainland species. For one, there is a lack of predators. Islands often lack predators that can limit the size and population of prey species. Without this threat, prey species can grow larger and more abundant, known as insular gigantism, as they have less need to hide or escape from predators. Larger sizes can also confer advantages such as increased defense, dominance, and thermoregulation. On the other hand, predators can grow smaller, which is insular dwarfism, as they have less need to hunt large prey or compete with other predators. Smaller sizes can also confer advantages such as reduced energy requirements or increased agility. Being on an island also reduces competition. There is often lower biodiversity than continents, meaning that there are fewer species competing for the same resources. In the case of insular gigantism, animals can expand their ecological niches and exploit new food sources that may not be available or accessible to smaller or larger animals. And the opposite is true for insular dwarfism, where some species reduce their ecological niches and specialize on fewer food sources that may be more abundant or reliable. Geology is arguably one of the most important factors when it comes to the effects of insular gigantism and insular dwarfism, mainly due to the influence on the size, shape, isolation, and age of the islands. For example, The size of an island can affect the amount of space and resource available for animals, as well as the degree of competition and predation they face. Smaller islands tend to have lower biodiversity and productivity than larger islands, which can limit the growth and population of large animals or favor the expansion and diversification of small animals. The shape of an island can affect the distribution and diversity of habitats and microclimates on it, as well as the exposure to natural disturbances such as storms and floods. Islands with complex topography and elevation gradients can offer more ecological niches and opportunities for animals to adapt to different conditions, which can promote speciation and variation in body size. The age of an island can affect the geological stability and history of it, as well as the evolutionary time available for animals to adapt to it. Older islands tend to have more eroded and weathered landscapes than younger islands, which can alter the availability and quality of resources for animals. Older islands also tend to have more endemic species than younger islands, which can reflect longer periods of evolution and divergence in body size. And lastly, the type of island can affect the origin and composition of it, as well as the productivity and diversity of resources. Distinct types of islands can be formed by different geological processes such as volcanic activity, tectonic movement, coral reef growth, and sea level change. These processes can create diverse types of rocks, soils, vegetation, and water sources on islands, which can influence the nutrition and energy intakes of animals. As you can see, there are many factors that can contribute to insular gigantism and insular dwarfism, but they may not apply to all cases or all groups of animals. Insular gigantism and insular dwarfism are not universal or inevitable outcomes of island colonization, but rather possible evolutionary responses to specific environmental conditions. But how do these phenomena help support the evidence for evolution? Well, evolution is the change in characteristics of living organisms over time, driven by natural selection and other mechanisms. Evolution can result in the adaptation of organisms to their environment, as well as the diversification of life into different forms. Insular gigantism and dwarfism are examples of evolution in action, as they show how animals can change their body sizes over time in response to different ecological pressures. They also show how animals can diverge from their mainland relatives into distinct forms that are adapted to their island habitats. Both phenomena can be seen in living animals as well as in fossils of extinct animals. They can also be studied using genetic methods such as DNA sequencing or phylogenetic analysis, which can reveal the evolutionary relationships and histories of islands and mainland species. Insular gigantism and dwarfism are not only fascinating from a scientific point of view, but also from a conservation point of view. Many island species are endangered or extinct due to human activities such as hunting, habitat destruction, invasive species introduction, and climate change. And by understanding the causes and consequences of insular gigantism and dwarfism, we can better appreciate and protect these unique and vulnerable animals. And that's it for today's episode on Earth SciShow. We've explored the wonderful and unique world of insular gigantism and insular dwarfism. We've also looked at the possible reasons why this phenomena occurs. And as long as the Earth continues to function in its dynamic way, new islands will be born and more animals will change their sizes. I hope you learned something valuable from this episode, and I'll see you in the next one. I'm your host, Mr. EarthGuy, and remember, stay curious.